Hi everyone, just going to make a quick video with some factorising techniques, going through a couple of questions that I was asked to help with. So the first question here is actually from exercise 6b in our textbook, and it's question 6. But rather than sort of talking about why I know how to do this question because of what exercise it's in, let's discuss how I know which technique to take because of the way the questions look. So the first thing I always want you to do when you're asked to factorise is to go through that short little analysis and break down what type of questions that you have. And then, as I've mentioned in class many times, I always look for the order that I'm going to factorise it in, and I work through this system. So I look for highest common factor, difference of perfect squares, perfect square trinomial, then a monic quadratic trinomial, non-monic trinomial, and complete the square as my final step. So let's have a go at question 6a here. And this question looks a little bit confusing, but the first thing that I straight away see is I have two terms, and in between them there's a minus sign. It's probably that minus sign that I spot before anything else. So when I tackle this question, I look over here and there is not a highest common factor, so I don't have to worry about the highest common factor, but it is a difference of perfect squares problem. Because I've got that minus, it's a difference of perfect squares problem. Alright, so as soon as I see a difference of perfect square problem, let's actually write out the question here so I've got good notes. I'm going to start by drawing two brackets, and I'm going to put a plus in the first one, a minus in the second one. Doesn't matter if you put your plus and your minus the other way around. And then I take the square root of the first part, and it goes into the first slot in each bracket. And then I take the square root of the second part, and it goes into the second slot in each bracket. Now I've got to spend a little bit of time here analysing and just checking, can I go any further? Absolutely I can by collecting like terms here. I know that minus 2 and positive 4 are like terms. They can go together. So this becomes x plus 2 and x minus 6. And I have fully factorised. Let's see that again now with question C here. A little bit different question C. So let's break this down a little bit further. We have 3 x plus 1 all squared minus 12. Okay, as I mentioned, we always start to work through this process over on the right when we're factorising. And the first thing I should every single time look for is the highest common factor. And this problem absolutely has a highest common factor. So the first thing I'm going to do is take out that highest common factor, which leaves me with that. Notice how I've got two sets of brackets. It can be a little bit confusing. Sometimes, just to help me visualise, I like to use a square bracket to show what's going on. So it's 3 times by everything in the square bracket. Okay, reassess, reanalyse. What have I got going on now on the inside of my bracket? Well, I spot straight away that minus sign. And I have 2 terms. So it's a difference of perfect squares problem again. So I'm going to put, for the difference of perfect squares part, my 2 brackets. And I'm going to put a plus in the first one, a minus in the second one. And the only difference this time is I've got a 3 outside the whole thing. So I'm going to put a 3 outside the whole thing. Now take the square root of the first part. It goes into the first slot. Take the square root of the second part, it goes into the second spot, and then tidy up my algebra. I have positive 1 and positive 2, which becomes plus 3, and I have a plus 1 and a minus 2, which becomes a minus 1. And what some students will do is they'll then put this 3 that's out the front, they'll try and move that into the brackets. You don't need to, you're factorising. So the 3 just sits out the front there on its own. Okay, so my final answer is 3 bracket x plus 3 bracket x plus 1. All right, final example here. Let's have a look at E. And for E now, same deal, except my problem has 2 brackets. But again, I just look at this as part 1, that's a squared term, part 2, that's a squared term, and I straight away spotted that minus between them. So if I want to factorise this problem, I straight away know it's a difference of perfect squares problem. So 2x minus 3 squared minus 2x plus 3 squared. We're going to have 2 brackets, one with a plus, one with a minus. Keep my colour coding going here. I take the square root of the first one, it goes in the first slot. I take the square root of the second part, it goes in the second slot. And I just have to be a little bit careful here because this minus sign, it's for the whole part that's in green there. It's for all of that. So I'm just going to put that in brackets to keep track. I can do the same on the left, but because it was a plus sign, it doesn't really matter. But because on the right-hand side, in our right bracket, this is a minus, that means everything here has to be taken away. And that looks like this. So I end up with, on the left-hand bracket, 4 x's and a minus 3 plus 3. Minus 3 plus 3 cancels each other out, they're opposites. On the right-hand side, I end up with a 2x, and I'll actually write this out the long way, a 2x minus 3 minus 2x minus 3. When I expand that bracket with that minus, it looks like that. And in this case, the 2x, take away 2x cancels out, and I'm left with 4x times negative 6. And 4x times negative 6 is negative 24x. And there is my factorised version. So although I've factorised, I've come out with a very simple answer. So you could argue that this was simplified rather than factorised. All right, that's the end of the first video.